Hi everyone, welcome to this short presentation on Introduction to Chromatography. Chromatography is a powerful analytical technique used in many fields including chemistry, biology and environmental science. In this presentation, we'll take a look at what chromatography is, its history and different types of chromatography.
The history. The history of chromatography can be traced back to the early 20th century when Russian botanist Mikhail Svet first used it to separate plant pigments. Since then, chromatography has become an essential tool in many scientific fields, and new methods and techniques are continually being developed. The term chroma means color and graphy means writing, so the term means writing in color.
So, what is chromatography? In simple terms, chromatography is a process that separates and analyzes mixtures of chemical compounds. This is done by separating the components of a mixture based on their physical and chemical properties. It is based on the principle that different substances have different interactions with a stationary phase such as a solid or a liquid and a mobile phase such as a gas or a liquid. The mixture is applied to the stationary phase, and as the mobile phase moves through, the various components of the mixture are separated based on their interactions with the stationary phase.
Now let's talk about the different phases of chromatography. First, the mobile phase. The mobile phase is an essential component of chromatography and plays a crucial role in the separation and analysis of mixtures of compounds. In chromatography, the mobile phase refers to the liquid or gas that carries the mixture of compounds through the column. The mobile phase is responsible for transporting the mixtures through the stationary phase, which is typically a solid or liquid that is immobilized in the column. The composition of the mobile phase depends on the type of chromatography being used and the specific requirements of the analysis. For example, in liquid chromatography, the mobile phase may be a buffer solution or a mixture of solvents.
The stationary phase. The stationary phase may be a column of adsorbent, a paper, a thin layer of adsorbent on a glass plate, etc., through which the mobile phase may move on. The mobile phase may be a liquid or a gas. The properties of stationary phase, such as its surface area, pore size, and charge, have a significant impact on the separation and analysis of the sample. By carefully selecting the stationary phase, researchers can control the conditions in chromatography system and achieve specific separations. It creates a barrier between different components of a mixture, so they can be separated based on their interactions with the stationary phase. Now, let's take a look at the different types of chromatography. There are many types of chromatography, each with its own specific applications. Some of the most common types include adsorption chromatography and partition chromatography. Adsorption chromatography is further classified on the basis of the combination between solid and liquid phase. It is classified as column and thin layer chromatography, and on the basis of combination between solid and gas, it's classified as gas solid chromatography. Now it's partition chromatography. Partition chromatography is further classified on the basis of the competition between liquid and liquid, and on the competition between liquid and gas. On the basis of competition between liquid and liquid, it is classified as column chromatography, paper chromatography, and thin layer chromatography. On the basis of competition between liquid and gas, it is classified as gas liquid chromatography. Now, let's get into more details of the different types of chromatography.
Adsorption chromatography. The adsorption chromatography is a widely used type of chromatography that separates compounds based on their interaction with a solid stationary phase. In this method, the stationary phase is a solid adsorbent material that is packed inside a column or coated onto a solid support. The mobile phase is a liquid or a gas that is passed through the column or over the solid support. It is widely used in various fields such as biochemistry, pharmaceuticals, and environmental analysis. It is often used as a purification step to isolate and purify specific components from a mixture.
Partition chromatography. The separation of components from the sample mixture is carried out by the process of partition of the components between two phases. Both phases are in liquid form. In this process, the immiscible solid surface coated with a liquid surface on the stationary phase is in the mobile phase. The liquid surface is immobilized by a stationary phase, which results in making it a stationary phase. The mobile phase moves from the stationary phase and components get separated. The separation depends on different partition coefficients. It is useful for separating and purifying a wide range of compounds, including lipids, steroids, amino acids, and sugars. It is also commonly used in the analysis of complex mixtures such as forensic science, environmental analysis, and bioanalysis. Now, let's go on through the other chromatographic terms. First, column, the tube or container that contains the stationary phase. Second, analyte, the substance to be separated during chromatography. Third, sample, the mixture that is being separated by chromatography. Fourth, elution, the process of washing the components of a mixture off the stationary phase and into the mobile phase. 5. Eluate, the mobile phase leaving the column. 6. Eluent, the solvent that carries the analyte. 7. Chromatograph, the equipment that enables the separation of a mixture. 8. Chromatogram, the visual output of chromatograph. 9. Retention time, the amount of time it takes for a specific component of a mixture to travel through the chromatography column and reach the detector. 10. Retardation factor. It is the ratio of distance traveled by a component to the distance traveled by the solvent front.
Applications of chromatography. Chromatography is a versatile and powerful technique that has a wide range of applications in many different industries such as medical and biochemical research, industrial analysis, forensic science, food quality control, pharmaceutical development, environmental monitoring, and so on. In conclusion, chromatography is a powerful tool in the field of scientific analysis. With the development of new technologies and methods, the possibilities of chromatography continue to expand, making it an ever evolving field with a bright future. Whether you are analyzing volatile compounds, proteins, or ionic species, chromatography provides accurate and precise results, making it a valuable tool for scientific research and industry.
Hope you all have got an idea on the basics of chromatography. With this, we would like to conclude our presentation. Thank you.